So now we continue our lesson. Actually, I want to solve some examples for you because the idea I have already talked about that. We want to use the notion of the definite integral to calculate the areas under the curves and of course the areas between two curves. Okay, so let me just remind you. Can you hear me, by the way? Yes?
Yes.
Okay. So what we have to do is to remind you here. So for example, do you remember when I was talking about the motivation behind the definition of a definite integral, we actually started with the idea of the area. Yes? So let me just remind you and now use it to solve practical problems in finding areas. So we learned that if I have a graph of a function like this, y is equal to f of x, and then if I am interested in the area below this curve above the x-axis between two limits a and b, vertical lines. So if I denote this area here under this curve by a, I mean exactly this part. That was our motivation starting point. We'll realize that the area is equal to the integral of function f of x dx from a to b. So this we already know. Of course, there are some limitations. So might be you have this one again. If, for example, if you are interested in this area, that is also the same thing. For example, if this is A, this is your vertical line. If this is B, this is also a vertical line. So again, if I ask you what is the area that I am showing you right now, you would say again the same thing, integral from A to B f of x dx. Okay? So it does not necessarily have to have some length here. Yes? So that's the area of this that you can see. But if you remember, we also talked about that it might happen that my function is below this curve, below this x-axis. Then if you calculate the integral, because integral is the Riemann sum, is the sigma of f of xk, for example, delta x. If of course my function is below, the value for f of xk is always negative, and delta x is positive, so this combination would be negative. I am adding up a lot of negative numbers, so definitely the answer would be negative. But what can I do? I can imagine that I flip this curve above like that, if I can draw it, and instead of calculating, for example, this area, I will calculate that area. From area point of view, these are the same. If they are exactly, of course this is not clear in my picture because I cannot draw it perfectly by hand. What I'm saying is that if you have a curve below this and you want to find this area, you can imagine that you flip this area above the x-axis. What you get, if this function is f of x, when you flip it, you get minus f of x. But what is happening is that the area, the flipped area, is exactly as the area that you want to calculate. So then it becomes integral from the area, in that case would be integral from a to b, the flipped function dx. But we learned last time that a number can be pulled out from this integral, so it becomes this. So it means that now you really understand why this minus sign comes in. Okay, so you can remember it in this way. So this is the way that you have to understand it if you want to. But if the area is below the x-axis, so you need to remember something, that if you want to calculate the area here, for example, between these two lines, A and B, if this is the area this time, this area is equal, because I need this space, so let me write this. This area becomes equal to minus integral from a to b f of x dx. And this is when, of course, this function is y equals to f of x. So this is something that you already know. And then, for example, if I give you a picture, this is also good to remember. I also talked about that, if I remember correctly, before. So you might have a function of this form. So for example, it starts here, goes up to here, and then you have it from A and then to B. And this is assume that this is your function y equals to f of x. Okay, and now let us consider this to be area number 1, and let me consider this to be area number 2, and I don't know, let us consider this, for example, area number 3. But if I ask you, using this graph, calculate the integral from a to b f of x dx, what can you do? Let me just teach you how you think about this. You would say that, okay, let us consider this point to be, I don't know, let us call it C1, and let me call this point C2. So do you remember that was a property of definite integrals? If I want to go from a to b, if I want to, I can break it up from a to C1 f of x dx, and then from C1 to C2 f of x dx. Do you remember that was a property of definite integrals? Then finally from C2 to b f of x dx. Okay, let us concentrate on the first integral. If I ask you what this integral represents, you definitely say that this represents exactly this area A1, because the area A1 is above the x-axis and the area is exactly equal to this integral. So if I want to, this becomes exactly equal to the area number 1. Yes? But now, if I ask you what this integral represents, you would say that this area is below the x-axis. So if I write A2 for this, that is wrong. We know that A2 is negative integral from C1 to C2. So if I multiply both sides by a negative sign, it means that minus A2 is integral from C1 to C2. So instead of this one, I cannot write A2, I have to write minus A2, yes? So minus, and then I will have A2, yes? And then again, for the same reason, the next integral is positive, and then I will have it like this, A3. Is that understandable? Good.
Yes.
And now there is one more thing I want to add, and I think it is very simple that you can immediately understand it yourself. What happens, so here you see so I have the boundaries of this region are two vertical lines, a horizontal line. They are straight lines, but only one of them is curved. And of course, you don't need to be worried about these things, because I told you that if you have this situation, so you can also have a boundary completely curved from above, but still you have a straight line as your boundary. You want to relax this condition as well. You want to just think, okay, what happens if we have all the way curves? Okay, so if we start from here, assume that you have two curves, two functions, okay? So let me draw another graph for you here. So, for example, I have this function. Let me, for example, draw it with green. So I have a function here for, let me call it y equals to f of x. And then I have another function, so let me, this function, let me call it g of x. And then I have these two limits here. For example, from point A up to point B. Now this time I am interested in finding the area between these two curves. Yes, I am interested in calculating this area. So what can I do? So this is the point. I want to calculate this area. So you see that now both these boundaries could be in principle curves, not straight lines. How can I calculate this area?
You calculate the larger one, and you calculate the smaller one, and you subtract.
Exactly. Exactly. So because I calculate this area, yes, this is possible. You don't need to even look at the lower graph. If I ask you what is this area below the green graph, it is easy. So I would write the integral. So let me call this area here. Let me put A here. So this area in this case is equal integral from A to B f of x dx. If I ask you what this is representing, you would say that this will represent this area. And now I calculate the other side. I calculate this area. How? By calculating the same type of integrals, but this time for function g. Okay, so this becomes integral from A to B g of x dx. And then of course the demanded area is the difference between them. And then last time we learned that that's a property of definite integrals, that you can write them as one integral and subtract the integrands, yes? So then finally I have this formula, the integral from A to B, the function which is above minus the function which is below, multiplied by of course dx. So here it's important to realize which function to write first. This is important. It doesn't matter if this area is below the x-axis or not. For example, if I have the same situation here, for example, let me consider another situation. It might happen that the graph of my function is some part above, for example, and the other function, for example, g of x, some part of it is above, some part of it is below, and then you want to still calculate this area. So you see, you want to calculate this area. One part of it is above, one part of it is below. You don't need to be worried about this in this case. So it is automatically taken care of. So if I want to write this function as before, y equals to f of x, and then let me write this function as before, y equals to g of x, and then let me write a again inside. So this formula is both for this one and for this one. Okay, and of course some of these curves could be lines as well, yes, so you don't need to be worried that they have to be definitely curves. No, they can, one of them can be a straight line, for example, like this. So you have a graph like this, and then you have a straight line, and then you want to find the area, for example, here. This will work. But in that type of formula, I have some limitations. One horizontal line have to be the x-axis, but here you don't need to be worried about having the x-axis. So let me just make it a small. So this is what information that we had already. I just wanted to summarize them in one place, and I think this is new. I don't remember if it is in Matrice or not, the area between the curves, but anyway, these are the formulas. Is that understandable for everyone? Okay, now let us do exercises. Determine the area enclosed by the curve, the x-axis, and the lines x equals to -1 and x equals to 1. Okay, because one of them is the x-axis, so you will have possibly this scenario. You don't need to be very careful, but of course if you draw the graph it is much better. You have a better understanding. But for example, assume that you draw the graph, it would be something like this. It's not a parabola, it's 2 times a function called cosine hyperbolic function. Okay, the graph, it seems similar a parabola, but it is not. Okay, and then I have x equals to -1, x equals to 1, so it means that I want to find this area. It's mentioning that the area enclosed by this curve, the x-axis, and 2 vertical lines, x equals to -1 and x equals to +1. Of course, if you draw the graph, it's easier. By the way, there is a nice feature in Geogebra. Let me try to show that one to you as well. If I can remember that. So you just start typing integral. If it is in English, might be you have downloaded it in Swedish, then you need to find the appropriate word for it in Swedish. And then integral between, you see, there is called some feature called integral between 2 functions. So here, no, I want to have one function. Yeah, this feature, you see, integral function start value, end value. So I will choose this, and then I type my function. What that function was e to the power of x, and then I go down. I used this button to punch, plus I use this button to punch e, and then to the power of -x. Then I go down, then I go here. It is from -1 up to 1. Yes? I don't know what happened. Ah, it's here. Oh, it already calculated, by the way, the area. But don't be very happy, because I always care about exact values. So let me move this a little bit higher. So here, and make it bigger for you. So you see, this is what I told you. This is the something like parabola. It is not parabola. You know that parabola should be a second degree equation. And then this is -1 up to 1, and this is the colored region that we want to find its area. I hope that you agree with me. This is exactly the simple standard problem. Okay, so let us go back and try to solve it. So here, area, let me call it A, would be the integral from -1 up to 1 e to power x plus e to power -x, and then dx. Yeah, this is very simple, yes, because you know what is a primitive function for e to power x is e to power x. What is a primitive function for e to power -x is negative e to power -x. And then I am supposed to calculate it between 2 limits from -1 to 1. So what I do, you can, for example, do it like this. You replace x with 1. So it is e minus e to the power of -1. You replace x with -1. It's positive. So then it becomes e to power -1 minus e. Then you go horizontally and subtract the number above minus the number below. It becomes e to power e minus 1 minus e to power -1 plus e. And then what you get is 2e minus e minus 1. And I always want you to keep the exact value. You are not allowed to give approximate values unless it is demanded in the problem. It's better to write the units. Okay, so this is the exact value that we get, 2 times e minus e to power -1. So let us check this with this one. So 2e, yes, minus again e to power -1. And you see that is exactly the answer. So the answer, approximate answer, is this one. That feature directly gave you the area below this curve, and you were able to find that. So yes, that's correct. Any questions? But don't do approximations unless it is demanded in the problem itself. Okay, let us go to the next problem. Determine the area of the region enclosed by the curve and the x-axis. Okay, in this problem you might say why the vertical lines are not given to you. Might be the graph of this function is in a way that you don't need them. Okay, so and then hopefully you don't need to know that much. You don't really need to spend time to do the graphing. What you know, it's a parabola, and there is a negative sign to it, so it should be a parabola with a maximum value. It might be here. If it is in this case, there is no area that they can ask us, yes, because this would be an unbounded region. So definitely it should be something like this. I don't know where, but I know it should be something like this. It might be to the left a little bit or to the right, but I want to find this area. And immediately I know that these are the roots of this. So you don't need to spend that much to have a very nice graph. Of course, having a nice graph in front of our eyes will always help, but you really don't need to do that. By this analysis, you realize that what you need to do is to put this equation equal to 0, because I am supposed to find the intersection points of this graph with the x-axis. So what I do first, I put this equation equals to 0. Okay, so I'm always easier to have x squared positive, so let me multiply it by a negative sign. And of course you can use either PQ formula or ABC formula to solve it, but this is even easier to guess two numbers. I put an x here, an x there, and I ask myself I need two numbers whose sum is -1 and product is -6. Because these numbers are so simple to guess, I prefer to factorize instead of using ABC formula. So then it becomes -3 plus 2, yes? The sum of these two numbers is -1 and the product is -6. So then this would imply that one answer is +3 and the other answer is -2. So what I told you, hopefully you agree with me that these are the limits of your integral when you want to calculate the area. So how can I set up my integral? So the area would be the integral from -2 to 3 of the function, and I have to calculate this. Okay, so what happens? What is a primitive function for 6? It's 6x. A primitive function for x is 1/2 x squared and 1/3 x cubed, yes? And then I have to calculate everything between two limits, -2 and 3. So then what I do, let me just do it like this. I put 3, 6 times 3 plus 1/2 times 3 to the 2 minus 1/3 3 to the 3. So this becomes 18 plus 9/2 minus 9. So it becomes 9/27/2, yes? And then I do -2 here, so 6 times -2 plus 1/2 minus 2 to the 2 minus 1/3 minus 2 to the 3. So this becomes -12 and plus 2 plus 8/3. So it's -30, it's -22/3. Am I right? Yes. And now I go horizontally, I write the number above minus the number below. So this becomes 27/2 plus 22/3. Let me take the common denominator, which is 6. 3 times 81, 2 times 44, and then what I get is 125/6. So the area is 125 exactly, 25 divided by 6 area units. Yes, is that understandable? So let me see what Geogebra actually predicts here. So let me get rid of that. And then what is my function here? I don't know if we have an option, because here there is no... Okay, we need to know... Yeah, so in principle you can draw the graph which is 6 plus x minus x to the 2, yes? So that is your parabola, and then you see that the roots are -2 and 3, yes? So then might be you can help this to write integral of my function. So let me type the function again, because I want to change this limits, plus x minus x to the 2, and then you go down. You realize it should go from -2, it should go up to 3, yes? And then you have this one, and when I enter that, I don't know. So this is the area between, so we calculate actually this colored area, and this turns out to be this, and then the answer that I got was 25/6, and that is exactly this answer. So you see, it's confirmed by Geogebra as well. Any questions? Okay, now let us go to the next example. So another type of examples that you need to know is something like that. You know, the function is not given, even though the logic is to use integrals to calculate areas. But who cares? We can also somehow cheat and do the other way around, yes? So here, if I ask you to calculate this integral using the information on this graph, you should be able to do it. Yes. By the information given, you see this is 1 unit, this is 1 unit. So if I ask you what is this line, it's -2 here, and what is this one, it is 2. And do you exactly want to find the integral from -2 to 2? But you need to know, if I go from -2 to 2, what are the areas that I am interested in? It's from here, so one part of the area will be here, and one part of the area will be here. Yes? And one part of the area will be here. Okay, so let me call this area into this one A1, and let me call, sorry, A3, and let me call this one, for example, A1, and that one A2. So when they ask you to calculate this integral, be careful, you have to calculate integral. According to what I started with, do you remember, if I want to write an integral for this, this means that the integral, let me change my color. So integral from -2 to 2 f of x dx, it is equal to negative area 1, because that part is below the x-axis, plus area number 2, and again minus area number 3. Okay? Then it means that I have to calculate these areas and then put them here. For this one, for area number 2, let me calculate area number 2 first. So what is area number 2? Let me write it with the same color. So area number 2, can you tell me how should I calculate? What is the answer for area 2? Okay, area 2 is also harder. Okay, so let me start with area number 3. So area number 3, what is area number 3? This is easy, because this is a right-angled triangle, and it is clear from there to here is 1 unit, and from here to here is 1 unit, so you know that I need to multiply these two and then divide by 2, so it becomes 1 over 2 area units. So A number 3 is this. Yes? Okay, but what can I do for area number 2 and area number 1? The problem is that you cannot guess. This point is not in a very nice point, grid point. So it is somewhere in between. You cannot guess how much is that. You have to calculate the exact value. And it is mentioned in the problem that you have to calculate the exact value. So what is your suggestion? How can I calculate this length? How can I calculate this length?
Calculate the k value of the line.
May you speak louder, please?
We can calculate the k value of the line.
Yes, and then?
We should get it to 3.
Okay, yes, the k value is 3, yes.
And then we know that it takes a third of the x value, a third x to get it 1 y value. So we know that it's a third.
Yeah, there are, yes, this is one way. So there are different ways. You can do it completely analytically. For example, what I say, I would, so let me just do it as you said. So one way, it's easy to see that the k value is 3 because I go 1 unit to the right, then the increase in y is 3 units. So k value of this line is definitely 3, yes? K value of the line is 3. But I also have one point of this line. For example, you can choose this point or that point. Let us choose that point. What are the coordinates of this point? X coordinate is -1, the y coordinate is 2. So this point has -1 and 2. And then if you remember, if you like, you can use this formula, I don't know, kx plus m, and then find the equation of the line. But let me use this 1-point formula. By the way, it's also good to know that this is the formula for the line with the k value k, which passes through the points x node and y node. It doesn't matter how you calculate that. So then instead of y node, I put 2. Instead of k, I put 3. Instead of x node, I put -1. It becomes +1. If I simplify that, it becomes 3x plus 5. Yes? I multiplied, moved 2 to the right. But then I want to find the x-intercept of my line. So it means that what I have to do, I put y equals to 0. If I put y equals to 0, then what I get is 3x plus 5 equals to 0. It means that x is -5/3. So because we want the exact value, we have to do this calculation. So we realize that now this point, actually this point here is -5/3. And now using that, I can calculate whatever I need, yes? So for example, let me call this length A, and let me call this length from here to here B. Okay, so I can calculate what is A. So what is A? A, this point is -2, yes? And this point is -5/3. So what should I do? If I want to calculate the distance, I need to write -5/3 minus -2. So the answer becomes +2 minus 5/3. So it becomes 1/3. So this is my A. Now that I have my A, I can immediately calculate area number 1. Area number 1 is also a rectangle, yes? So I need to multiply this by that and then divide by 2. So what will happen? It becomes 1/3 that we just got it, multiplied by the height, which is 1 unit clear from that, and then divided by 2. So this means that area 2 is 1/6 area units. Yes? And then if I want to calculate B, that's also clear, because from here to here, this is -5. I want to find the length. The final point is 1, the initial point is -5, so I find the difference. So what is B now? B is 1 minus -5/3, so it becomes 1 plus 5/3, and it becomes 8/3. So this is the length of B, but this rectangle is not a right angle triangle, but this is also simple because I know the height. The height is 2 units, and the base I just calculated is this. So again I can calculate A2. So what is A2? A2 is equal to the height, which is 2, multiplied by the base, which is 8/3, and then divided by 2. So this means that that was my mistake. Area number 2 was 8/3 area units. Okay, so and then let me fix it. This would be area 1, so that is 1. Okay, now everything is ready, so I put this in this formula and I get my integral. So the integral becomes from -2 to 2 f of x dx is equal to minus area number 1, which is -1/6, plus area number 2, which is 8/3, and minus area number 3, which is 1/2. So I can take the denominator to be 6. It becomes -1 plus 16 minus 3, and then it becomes 12. Is that right? Yes, it becomes 2. Okay, so the answer to this, if I haven't done any mistakes, it is equal to 2. But let me ask you one question. Do you think if it can be negative at the end or not? In general, not for this problem. Of course, in this problem, if I have done the calculations right, the answer is positive. But can it be in principle negative?
I mean, if we're calculating the area, then a negative area should be possible.
Yes, should be possible, because you see in this picture, it is easy to see that these parts that are below, even though I have 2 of them, but this seems much bigger than the sum of these 2 areas. For example, if I have this picture like this, and then I will go from here to here, you see that I have 2 ones which will contribute negatively and 1 part contribute positively. It's completely clear that this sum is bigger than that one. So for this case, it would be negative. So don't be worried about if an integral is negative. You have to be worried if the integral is going to represent an area, and in that case, if you get a negative number, it means that you are making a mistake somewhere. Okay? And then one thing that you also mentioned about using geometry, that's also possible. For example, you see, if I draw a line from here, this triangle here and this triangle here are similar. Do you agree with me? Why they are similar? Because this angle and that, and let me make it bigger so that you can see it. I am saying that this triangle is similar to this triangle. Why? Because this angle and that angle are vertical angles, so they are equal in size, and one angle here is 90, one angle here is 90. So these two triangles that I mentioned here are similar ones. When they are similar, it means that the ratio of this to this would be equal to the ratio of this to that. Yes? So if you want to, I write it and then clean it. So what I want, so let me call this one. So assume that this is your x. So assume that I don't want to mess up with this picture, but okay, so let us consider this x in your head. This is something that I want to find. So I would say that A over x is equal to this side, which is 1, divided by this, which is 2. And then I realize that 2a is equal to x. Yes? 2a is equal to x. So it means that 2 times this is equals to that. So it means that it is clear that what should happen. So it means that if I divide this into 3 pieces, each piece is 1/3. But I want to know about this. This was -2, so I just add 1/3 to it, so it becomes -5/3. So this is purely geometrical. You don't need to find the slope, equation of the line, I don't know, intersection. So you can also analyze it using geometry, purely geometrical arguments. But let me just get rid of that. And that's also completely okay. It was more closer to what you were saying, I think, as you were answering. So that's one type of problems you need to know as well. So I would say that this is a little bit cheating. Here I am using the area to calculate an integral, even though integrals were invented in the first place to calculate the areas, not the other way around. But we can also sometimes use it the other way around. Okay, for this question, I think I have given you another example. This doesn't look like to calculate an area at all. I am just asking you determine the exact value of the following integral. Okay, so might be if I give this question without that you know about, I am talking about areas, this would be a hard problem. Because you need to wait for a long time to find a primitive function for this. You will probably learn it if you go to a technical university at the end of this calculus courses. So what I'm saying is that you can in principle find a primitive function for this, but not at this level. Even if you can do it, I will not prefer to solve it in that way that you will learn in the future. Do you have any idea how to calculate this integral? You know that there should be something related to the area. Let me start with something. Hopefully you remember that this integral can be decomposed into 2 parts. Yes? Whenever one part of an integral is easy, so one way is to decompose the integral using the properties of definite integrals. Okay, at least it is better than doing nothing. Yes? This I can calculate. It's very simple. This one, it entails to find a primitive function for this. But finding a primitive function for this is not at the level of your lesson. So what we can do? Either we should just ignore it, or you should find a way to be able to answer this one without Newton's formula. Because if you insist to use Newton's formula, you have to find a primitive function. Okay, so let me give these names. Let me call this integral number 1, integral number 2. Integral number 1 is simple, yes? I can use Newton's formula. So what can I do? I can just write it as 1/2 x squared. It goes from 0 to 3. It's very simple that it becomes 9/2. So I1 is just 9/2. But do you have any idea what to do with the second one? Let me help you in this way. Assume that you don't know the primitive function for this. Is there any other way to calculate this without primitive function for you? This is so simple that might be you will be able to answer. Is there any other way to calculate it without this very simple Newton's method? Using the area interpretation?
We draw the graph.
Thank you. Yes, we draw the graph So because this is not part of the solution, let me just draw it with a different color. So you draw the graph, because the graph of that is simple, y equals to x. So hopefully you know that this is the graph of y equals to x. Let me make it better. So okay, and then you will concentrate on the limits from 0 to 3 and then find the area. So 0 is here, so assume that here is 3 for okay, and then you go up and then you calculate this area. But calculating this area is simple for you. Y is equal to x. So if I ask you what is this height, you would say 3. Why? Because x is 3. When I put it here, y also becomes 3. And here is 0. So then the area is equal to what? 3 times 3 divided by 2. And you get the same answer, 9 over 2. Of course, here we had an alternative to do that, and that was Newton's formula. But here it seems that we don't know how to find the primitive function, so let us start cheating again. Let us use the area interpretation to solve an integral, even though the logic, as I told you, should be the other way around. So then it means that, can I come up with the graph of this, which is not, of course, a standard, but that's the problem. Can you tell me what is the graph of this function? So hopefully you understand the logic. The logic is now to find the area, find the graph of this, and hope that the region is something that I already know how to calculate its area. If that is the case, then I can cheat and use that to answer this integral. But let us try to draw this. Of course, I can use Geogebra to draw that, but I don't mean to do this. So can you tell me how can I come up with this? First of all, y is non-negative. Because y is equal to a square root, it cannot be negative. So it means that the graph of the function will not go below the x-axis, because y should be always non-negative. Okay, let me square it, and then it becomes 9 minus x squared. I don't know if you remember from Math 3C, hopefully, you can immediately realize what is this. Do you realize? I moved x squared to the left. Okay, you might so in mathematics, I don't know, memory is also something very helpful. So let me mention that in Math 3C we learned about that x minus a to power 2 plus y minus b to power 2 equals to a number to power 2. This is an equation for the circle. Radius of the circle is r. Center of the circle has coordinates a and b. This, if you have forgotten, it's important to refresh your memory. And by the way, it's not important to remember. If you know mathematics, hopefully you realize what is this one. If I have a point with x and y coordinates, this is y, this is x. What is x squared plus y squared? This is the distance to the origin. Yes? So this tells you that the distance to the origin should be equal to 3. Okay? So this equation is interpreted in this way. The distance of my point to the origin is equal to 3. So it means, what is that? I want the point whose distance from the origin is 3. All the points. So it becomes a circle. Yes? Centered at the origin with radius 3. But I am not allowed to go below the x-axis because y is non-negative. So this is not a complete circle, it's a semicircle. Yes? So if I want to draw the graph of that, what I do here, the graph of this function, the graph of this is the whole circle, But here I am limited to non-negative values for y, so it would be a circle with radius equals to 3. It's hard to draw it by hand, but something like that. Yes? And then here would be minus 3, here would be 3. Are you convinced or not? If you're not convinced, we can go to Geogebra and check it. So, yeah. Let me take this away and then let me draw the graph. Y equals to square root. Let me use this button. And then I have 9 minus x to the 2. Yes. And then hopefully you see that this is the semicircle that we were predicting. Okay? Anyway, now what is the integral? The integral is the area under this curve, but not from minus 3 to 3. It is limited from 0 to 3. So it means that this integral represents this area. But do I need integral to calculate this area? No. Because this is a quarter of a circle, and we hopefully know the area of the circle. So the area of the full circle is what? So I would say that I2, if I want to calculate I2 is 1/4 of the area of the circle whose radius is 3. But you remember that the area of a circle is pi r squared. Yes? And then what would be the answer? It would be 9 pi over 4. So finally, the answer to this problem is what? Is I1 plus, I1 is 9 over 2 plus I2. So the answer would be 9 over 2 plus 9 pi over 4 area units. Is that understandable? So sometimes this is important. It's still, even though the logic, the reason that integrals were invented in the first place was to calculate the areas, not the other way around, but sometimes it is helpful. And I think GeoGebra should also some features to calculate this integral, because is what you do, you can write integral. Let me see. So no, this is integral. Okay, integral. If I don't know why GeoGebra cannot give you the exact value. This is a little bit strange.
Maybe it's called exact.
You mean exact? Let me just. I don't know this. I don't know how can I find all these syntaxes. No, if I exact doesn't work. So let me just see that integral of function and variable from this one and that one. Is there any other thing that you see? No. Might be I should be able to set up everything to exact by setting it up. I don't know. Let me just do it. This is x plus a square root of 9 minus x to the 2. Yes, do you remember? From 3, from 0 to 3. This will give me, of course, this is very strange. Oh no, that's not correct. That's correct. The reason is that the GeoGebra is drawing the graph of this one. You see, the graph of this one is complicated. We don't know how to draw the graph of this very easily. The graph seems to be like this, okay, which we don't know what that is. But I didn't do that. I used Newton's formula to calculate the first bit, and I used the area interpretation to calculate the second one, and I then merged them together, okay. But hopefully the answer that I get should be the correct answer at the end. Let us test that one. The answer I got was 9 over 2 plus 9, let me write brackets, 9 times pi, pi is this one, and then go down 4. Yes, and now you see that I was correct. The answer that GeoGebra provides here is just exactly the answer that I got, at least up to 4 decimal points, and then hopefully that's correct. I know that I can increase the number of decimal points, but it should be possible to give exact values. Okay, so let us have some rest. But yes, please.
Is this problem on the level of the book?
I don't know. Don't ask these questions from me all the time. Who knows about the levels? Try to enjoy, okay? You got a good grade in exam, that will happen again. Yes? Yeah, you shouldn't be concerned about these things a lot. Actually, when I was...
Baba?
Yes?
I have another question.
Yes?
You know, like formula r squared equals something something. That one you used to solve this question. When did we learn this formula? Because I don't remember.
No, actually this formula is cheating, I told you. PR squared is coming from integral calculation. So yes, but this is why I'm saying it's a circular argument. But who cares? We want to get the answer, so at this level it's okay. But if you want to prove the formula pi r squared, there is a geometric way to do that. Not very geometric. So the one way is to look at the polynomials and increase the number of edges to infinity. So you write an area for a polygon with n sides, you get an area. That is not hard, because a polygon can be partitioned into triangles, and then you find, so let me for example explain it here. So if you want to find the area, one way to find the area of the circle is to assume that I have a polygon inside it. Calculating the area of the polygon is easy because I can partition it to triangles. So, and then I calculate each area. But of course this is a smaller than the area of the circle. But if I increase the number of these edges, the areas become closer and closer to the area of the circle, and if you know how to calculate the limit and send the number of edges to infinity, that number that you get would be the area of the circle. That would be one way. Another way is to know how to calculate a primitive function for this. That will be the second way. Yes, but here you are right. In principle, if I want to be 100% logical, but as I told you, this is not that much cheating, because finding this has another way, as I just described it for you, and it was known for ancient Greeks as well. I don't know, did I answer your question or not?
Yeah.
Okay, so now let me go to another one. Let us see what happens if we go here. Wolfram alpha, that also is good in calculating this, but it's very... Yeah, I think they are using AI, so they more or less understand what I mean. I don't need to write the exact syntax. So integrate. Of course, this is based on mathematical, so I somehow know how mathematical works. So x plus, then I know the square root r3, so, and then I just punch brackets or whatever, probably it's not important, 9 minus x to the 2, and then I need to give the variable, which variable is that and where it goes from. X goes from 0 to 3, yes, and then I close it and I enter. And then let us see what happens. First of all, GeoGebra writes something, and see, this is the exact number that we got. And you see, GeoGebra is also giving you a primitive function. Sorry, this is not GeoGebra, Wolfram. So this is the primitive function for this function. So x squared over 2 you were able to guess. A primitive function for x is x squared over 2. But a primitive function for this is from here up to here. 1 over 2 is square root of 9 minus x squared times x plus 9 over 2 sine inverse of x over 3. Okay? Something like that. And if you pay... Okay, when I click on it, yeah, you see, it's just showing you to motivate to pay them. Integrate the sum term by term. So it's like a teacher If you pay a little bit money, they will give you how to write the solution, not just only the answer, but the full solution to the problem. Anyway, the number that we got is this number. Is there any way that I can simplify this to my answer? I just clicked on it. You see, this is the answer that I got. So GeoGebra this Wolfram is very nice. So it is probably knows what was my intention. Just by clicking on it, it predicted that I need to do something like this. And if you remember, 9 over 2 plus 9 pi over 4 is exactly the number that I got here. Okay, so hopefully you realize that finding a primitive function for that was not that easy at all. Any questions here? Okay, let us go to the next problem. In the following figure, determine, so we have up to 1140. So let me hurry up a little bit because I want to finalize these two topics here. So in the following figure, determine the exact value of A so that the colored area be this number, 7 over 3 ln of 4 area units. Okay, in principle, a starting point is not hard, but might be if you have forgotten what I have told you in the previous lessons, then it would be hard for you. So here we know that the area is given to me here. It's 7 over 3. This is another type of problem. They are also sometimes some type of these problems in the book. The area is given, one of these limits is wanted. Okay, so I know that the integral from this number, by the way, this is E, the Euler number, and that is also the Euler number here in the function. So this tells me that the integral from E to this unknown number A of my function is equal to that number. Okay, then my goal is to find A. Okay, here there is no cheating. We cannot cheat at all because this is a curve, so we don't know exactly what is the area here. Of course, the area is actually given to us, so we want to find A. So it means that we have to use Newton's formula. For Newton's formula, I need to come up with a primitive function. But can you help me to find the primitive function for this guy? No one remembers, yeah? Okay, I want to give you some hint. What do you think about this? So let me write something. Does something rings a bell? Ring a bell here? Do you remember I talked about this combination? I said that some of the problems in the book uses this combination. No?
That's the primitive function of M.
Yes. So it means that if I ask you what is a primitive function for this, if you remember, the answer was ln of absolute value of u. Of course, plus a constant, but constant doesn't matter when I am doing indefinite integrals. But the problem is that this is not exactly in this form. So let me just write it down here. So I want to calculate a primitive function for 7 over 3x plus e. Yes? I can write it in this way. I can write it as, first of all, I can pull this 7 out from primitive function. It becomes 1 over 3x plus e. But does this function have exactly this form? Not exactly, because the derivative of this does not appear in the numerator. The derivative of this is 3, but in the numerator it appears 1. But you know how to solve it if you remember the previous lesson. So what I can do, I can divide by 3 and multiply by 3. Yes? And now everything is in order, because 7 over 3, instead of that, I can write 3x plus e. In the numerator, I can write 3x plus e derivative. Do you agree with me? If someone asks you what is the derivative of this, you would say 3, and this 3x plus e is the same. So what I have written, the function for which I want to find the primitive function I was able to write it in this way, but now using this formula I can find a primitive function for that. It is 7 over 3 ln of absolute value of 3x plus e. Hopefully now you can follow. Now that a primitive function is clear, now let me calculate my integral. So the integral from e to a of 7 over 3x plus e dx is this primitive function from e to a. Okay, then what I have to do, I have to put, by the way, do I need absolute value sign? So let us get rid of it, because x is definitely positive. You see, I am on the positive side of x-axis. When x is positive, multiplied by 3 positive, e is positive. So I really don't need to bother about absolute value sign. So if you don't mind, let me remove it and change it with a pair of brackets. Now this becomes 7 over 3 ln of, I replace x with the upper limit, which I don't know, plus e, and minus 7 over 3 ln, I replace x with e, so it becomes 3e plus e. That's it. That is my integral. But of course I have to do some simplifications, so I factor a 7 over 3 out, then I will have ln of 3a plus e, and then what happens here, 1e plus 3e becomes 4e's, so it becomes ln of 4e. And then if you remember, ln of, what is ln of 4e? So let me write it in this way. So ln of 4e is, just we keep it in this way, but if you remember, ln of x minus ln of y is equal to ln of x over y. Yes? So this becomes 7 over 3 ln of 3a plus e divided by 4e. That's it. This is the simplified version of my integral. But I already know the answer. The answer to the integral on the one hand is this, on the other hand is supposed to be equal to that. So what I need to do is just to equate these two values. So therefore, what happens is that 7 over 3 ln of 3a plus e 4e should be equal to 7 over 3 ln of 4. So I have intentionally given you this number so that you can eliminate this from both sides. And then ln of something is supposed to be equal to ln of 4. So what does it mean? It means that this expression should be 4. So this means 3a plus e divided by 4e should be equal to 4, and I'm looking for a now. My only unknown in this equation is a, because e is the Euler number, 2.7 something. So I multiply everything by 4e, so 3a plus e becomes 16e, and then 3a becomes 15e, and then I divide by 3, so a becomes 5e. Okay. Is that correct? Understandable? Of course, I have seen some of these exercises in the book, but not probably as hard as this one. But there are some problems that you know the integral, but you are supposed to find one of these limits. So I wanted to combine some problems together so that you enjoy a lot. Hopefully you are enjoying, okay? Don't worry about the exam. Thinking about the exam will spoil the fun of these things. exam, you have already done that. That would be exactly at the same level. If you did it once, you can do it again. Okay, any questions? Good. Let us go to the other problem. Now, this is the first time that we are dealing with two curves. Okay, I saw that the problems in the book for the two curves are actually hard. Okay, harder than the usual problems in the book. So here, let me read the problem for you. The colored region is the region between the graphs of the functions y equals to sine x and y equals to sine of 2x. I haven't written them down on the picture intentionally, and I haven't used the grid paper here because I want to make sure that you understand what to do if they are not given to you. Determine the area of the colored region. So it's clear that I want to calculate the total area here. Okay, first of all, tell me, is the green one for sine and the blue one for sine 2x, or the other way around? So in principle, which one is which?
The blue one is sine 2x, right?
The green one is sine 2x. I would say no. So well, let me ask you, so any other opinion?
Y equals sine 2x has a faster
So what was the name of the terminology that you insist to use? Yes, what was the name?
periodicity.
Yeah, period. Yes, period. What is the period of sine? The period of sine is 2 pi, but the period of sine 2x is 2 pi over 2. So it is pi. So might be you are right. No. So it means that the period, one of them has period pi, the other one has period 2 pi. So this is clearly one period. But this one is not a period, this is half a period. So if I complete it up to here, it's a total period. Okay, so which one is which? The period of the blue one is half of the period of the green one. Yeah, everyone agrees? Yes or no?
Yes.
So the period of the blue one is from here to here, but the period of the green one is from here to here. So the period of the green one is 2 times the period of the blue one. Okay, so that should be this one. So the green one is sine x, so let me write it with green. And the blue one is sine 2x. Okay. Now I want to calculate the area between these two curves, and there is another problem coming in. So do you remember, if I go to the first page that I was teaching you, if I want to write the area between two curves, it is extremely important to realize which one is on top, which one is below, because you have to start with the one on top minus the one, otherwise you get an extra negative sign at the end, which doesn't make sense for the area. Okay, so here the problem is unfortunately not that easy. This is actually one problem similar to the book. On this part, the blue one is above the green one, but after we pass this point, suddenly the green one is above the blue one. Okay, so it means that I have to break the integral before this point and after this point. There is also another problem. The paper is not a grid paper. I don't know what that is. So it means that you have to find it. There are some problems in the book of this nature. Okay, so can you tell me how can I calculate this number which I don't know?
If you sine x equals sine
Yes, you need to solve the system. You put y, so let me just do it quickly. Y equals to sine x and y equals to sine 2x. So you need to remind yourself of what you learned in trigonometry. So sine 2x is equal to sine x. If two sines are equal, either the angles are the same, of course plus 2n pi, or one angle is pi minus the other one plus 2n pi. So from here I get x is 2n pi. I moved x to the left. From here, when I move x to the left, it becomes 3x, and I divide by 3. It becomes pi over 3 plus n pi. Okay? Of course, how many answers I get? I get infinitely many answers. One for each choice of n here, one for each choice of n here. But here, if I ask you what is this number, hopefully you can tell me, because this is the period of this blue one, so immediately I realize here is pi. Okay, we realize that this is the period of the blue one. So it means that I am only interested not in all infinitely many answers. I am only interested in those answers that are smaller than pi. So what are the, and positive, not negative. So here, if I start giving n to 0, the integers to this, the first one would be 0, the second one suddenly becomes 2 pi, which is actually far away from the where I am looking for. So forget about this. This will not generate anything in between 0 and pi. But what about this one? Yes, it will generate. Do you agree? Because, oh, I made a mistake. Yes, sorry. I made a mistake in dividing. You didn't tell me. So let me repeat. If I move this to the left, it becomes 3x equals to pi plus 2n pi. When I divide by 3, I have to divide everything by 3, not only the first one, but also the second one. So this is 2n pi 3. Sorry. Okay, so you see that if I want to find the answer here, I start putting, if I put negative value for this, it becomes minus 2 pi over 3 plus pi over 3. I will go to the negative part, which I am not interested. What happens if I put 0? If I put 0, this is gone. I will get pi over 3. And if I put 1, it becomes pi, which is of course correct because pi is also an intersection point. So you realize, hopefully, that x equals to pi over 3 is the number that you are looking for. Agree? Everyone agrees? Okay, so here we realize that this point is pi over 3. Now let me call this one area number 1, area number 2. If I ask you to calculate area number 1, how do you calculate that? It becomes the integral from 0 to pi over 3. Which one is the top function? Which function is on above? The blue one, which is sine 2x, minus the function below, plus so let me just calculate this until the end. So let me just do it quickly because they are simple. A primitive function for this is negative 1/2 cosine 2x. A primitive for sine is minus cosine, so it becomes positive cosine. I don't want to spend so much time on it because I think it is easy. If you put pi over 3, cosine of 2 pi over 3, I have it in my memory, it's minus 1 over 2, so it becomes 1 over 4, and then you have plus 1 over 2, and then if I put 0, it becomes minus 1/2 plus 1. So don't worry about this, just patiently put this number here, put this number there, and subtract them. So what happens is 3/4, I don't know why this changes the color, so 3 over 4, and then I have minus what? 1/2. So it becomes 1/4. So this is area 1. Okay? And now what you can do, you can calculate area number 2 as well. So what's area number 2? The same integral, but you need to be more or less the same integral, sorry. But you need to, first of all, what are the limits? Here I go from pi over 3 to pi, so it is pi over 3 to pi, but this time the green function lies above the blue one. Yes, so I need to write the green function first minus the function below. So, and then you have to calculate this integral as well. So let us just do that quickly. It becomes the primitive function for sine is minus cosine, the other one is minus a half cosine 2x, and then you have to calculate it between pi over 3 and pi. And then if I put pi, it becomes 1, the other one is 1/2. I am putting pi here, cosine of pi is -1, so this is why I wrote 1. These are simple calculations. And then I put pi over 3, it becomes minus a half. And then what is that one? 2 pi over 3 is minus a half, so it's minus a quarter. So that becomes 3 over 2, 3/4, negative positive 3/4, and then 6, 9 over 4. So area 2 is 9 over 4 area units. Yes? And then the total area would be the sum of these two numbers, 1 over 4 plus 9 over 4. It's 10 over 4, which is 2.5. Let me write it in decimals this time. Hopefully I haven't done something wrong. Let me just check it with Geogebra. Is that understandable for everyone? So don't think this is higher than the level of the book. We don't have that much time. The next one that I wanted to solve, it's from national exam. And actually, I would say it's a very, I don't know if in the book they have categorized this problem as a level 2 problem, which I don't believe it's a level 2 problem. It should be a level 1 definitely problem. Okay, if I cannot find time, I will solve this problem later for you, but I want you to think about that. But before that, we have a little bit of time, so let me also use the feature in GeoGebra here to see how this will work. So let me get rid of all these things. Okay, and then there is also another feature. I saw it in GeoGebra. So it is integral between, you see, integral between this one without that boolean evaluated at the end. So here, so you need to give two functions. So what are your functions? You just type them. Hopefully GeoGebra will take care of it, everything. So I just punched them. I don't care which one is on top, which one is not. So it is sine of x, and then the other one is sine of 2x, yes, and the starting value is 0. Of course, I need to give the final value as well. So the final value is pi. Okay, so this is exactly what we were looking for, but the answer is 2. Why? The answer should be, what I got was 2.5, so I have to go back and recalculate things. Okay, so hopefully you understand what's going on. So these are the curves that we were looking for. I haven't made any mistakes in typing. Yes, it is from 0 to pi. Okay, so according to GeoGebra, the area should be 2 area units. So let me see what I have done wrong. Just check it quickly. So it is this one correct, this one correct. I put pi over 3. 2 pi over 3 is 120. That's correct. That's also correct. Then I put 0. Then I put 0 here. Yeah, this seems correct. 1 minus 1/2 is 1/2, but there is a negative sign. And then I have 3/4. So 2 over 4. So this seems correct. but might be I have done some mistakes here. From pi over 3 to pi. This is negative, this is positive. I put pi here, it becomes 1. 2 pi, cosine of 2 pi is 1, that is also 1. Minus, I put pi over 3 here, I put pi over 3 here, so everything seems right. So this is 3 over 2. And this one is 2 over 4 plus 1 over 4, 3 over 4, 6 over 4, 9 over 4. This is strange. Do you see any flaws in my calculations? Have I done anything wrong here? So let me find this intersection point to see where is this point. This intersection point is this one. And what is pi over 3? Pi divided by 3. So this is something might be we have done wrong. We calculated the wrong number. Do you see any mistakes in my calculations? According to Geogebra, if I want to find the intersection point between these two, if I have done this right, this shouldn't be that one. Pi over 3 is approximately this number. But according, so if that's probably that's not the right point. It's really unfortunate. The only thing that I can see is let me make it clear so I have a little bit of time. So let me just draw them differently. Y equals to sine of x. Let me just draw that, and then let me also draw y equals to sine 2x. Okay, so the green one was sine x, so that is correct. And then if I ask Geogebra to find the intersection point, I don't know if it can find it for me or not. Yes. Yeah, so this I calculated correctly. You see, when I was thinking that this is the right point, it was not. So you see, pi over 3 is this number. And now Geogebra finds that the intersection point is point B, and the coordinate is exactly the same. So I calculated pi over 3 correctly. So we don't have any problems there. But when I calculated this one, let me double check it again. This becomes negative. This becomes positive. From 0 to pi over 3. Cosine of 2 pi over 3 is negative 1/2. I am sure about that. So it becomes positive 1 over 4. And then I put it here, that's correct. Then I put 0 here. Cosine of 0 is 1. Cosine of 0 is 1. But then this one becomes 1/2. And there is a negative sign behind that, so it becomes negative 1/2. And this is 2 over 4, so it becomes 3 over 4. And then it becomes 2 over 4. When I subtract them, it becomes 1 over 4. So that is correct. And then when I calculate it the other way around, this primitive function is this, a primitive function for this is this, definitely, from pi over 3 to pi. I put pi here, cosine of pi is negative 1, so it becomes positive 1. I put pi here, cosine of 2 pi is 1, so it becomes positive 1/2. Then subtraction, I put pi over 3 here. Cosine of pi over 3 is 1/2, there is a negative sign. And then when I put pi over 3 here, it becomes 2 pi over 3, cosine is negative 1/2. So this is also correct. Then if I add these two numbers, it is 3 over 2. And then what happens if I calculate this one? it is 2 over 4, 3 over 4, it is positive, so it becomes now 6 over 4 plus 3 over 4, 9 over 4. And then 1 over 4 plus 9 over 4 is 10 over 4, which is 2.5. I don't know. It's crazy. Yeah, okay. So let me calculate the integrals. Integrate. What was the first one? Sine of 2x minus sine of x, and then x goes from 0 to pi over 3. Let me write pi over 3. Hopefully he knows what he's doing. Okay, so let me see what is the first integral. I got 1 over 4. So you see 1 over 4 is correct. Okay, so the first integral I haven't done any mistakes, but let me change the signs here. Now this is positive, this one is negative for the next one. And then the integral is supposed to go from pi over 3 to pi. Yes? Oh, come on. This is 9 over 4. So I don't know why is it possible that GeoGebra is getting, so this the answer that I got is completely correct. I was shocked actually. So this answer was 9 over 4, the other answer was 1 over 4, so if I add them it becomes exactly that one. So I don't know why this is giving you 2. Do you see why? Okay, that is a very strange thing. I need to think, because I'm completely sure I double checked the calculations over and over again. There is something that GeoGebra produces 2 and I don't understand why. But when I check it with alpha Wolfram, you see that the second integral is also 9 over 4 as I did. The first integral was 1 over 4. When I add them in principle, it should be the same answer. Okay, so I will think about this, why this is happening by GeoGebra. You can also think about that, but what I want you to do, just take a screenshot from this problem. Please try to think about this problem. The next time I will just solve this problem for you, and then everything in this part is finished, and I will start the last part, which is finding the volumes using the integral. Whatever I haven't taught will not be included in the exam. I will definitely go to the next chapter, and I want to teach complex numbers in a very extensive, good way. I want enough time, then I will come back to cover these things. But you will never have exams for them, okay? Okay, thank you very much.